Hey guys, this is Shayan and today I'll be talking about longest common subsequence or LCS. LCS is a problem that can be solved using dynamic programming. Well, this problem has a lot of usage in bioinformatics, genes comparison, and in general text comparison. Today I will tell you what exactly this problem is and how we can solve it. I will also implement it for you and we will comprehend what it really is. Okay, this problem LCS says that assume that you have two strings S and T. We have two texts or strings and we want to find the longest string, the longest possible string that is the subsequence of both the first string and the second string. First, take a look at what a subsequence is. Well, assume that your string is like Cheyenne, and a subsequence is a string that you can achieve by removing some of the characters. For instance, you can here choose S and Y and A and remove this H and A and N and you will have SYA. So SYA is a subsequence of Cheyenne. Keep it in mind that subsequences do not need to be consecutive. We have another thing named substring. Substrings need to be consecutive. So, for example, SYA is not a substring of Cheyenne, but it is a subsequence of Cheyenne. A substring should be an interval. It should be a consecutive part of your string. So any subsequence is a substring, but any substring is not a subsequence, and this is the difference between subsequence and substring. Now the problem longest common subsequence wants you to find the string with the most possible length such that it is the subsequence of the first string and also it is the subsequence of the second string. For instance, if your first string is Cheyenne and your second string is like Saman, then here you can say that SAAN is both a subsequence of the first string and it is also a subsequence of the second string, because in the first string I have this SAAN and also in the second string I have this SAAN. So SAAN is a common subsequence of these two strings. And since we do not have any other subsequence which is longer than this string, and it is the subsequence of both of them, it is also the longest common subsequence. Therefore, the longest common subsequence is this, and the length of it is 4. We can also have more than one LCS. For instance, in here, if my string is like ABC and ACB, both AB and AC are subsequences, longest common subsequences of these two strings. But the length of two of them are equal, because otherwise if it wasn't equal, one of them was not the longest possible string. So the length of it is a constant. It's not possible to have multiple results for that. But the strings themselves can have multiple ways, like here. So now the question is that how can we calculate it? How can we find out what LCS is? How can we find the length of the longest common subsequence? And why is that even important? How can we use this value? Well, for instance, assume that you have an exam and two students have submitted their answers. One way to find out if they cheated or not is to find the longest common subsequence between the two texts that these two students have submitted. We can, for example, look at the LCS as an indicator to understand that how much two strings or two texts are similar to each other. And by doing that, this can be a good indicator to understand that if these two students cheated or they didn't. So this is the usage of LCS in the real world. Okay, so now let's calculate it. Let's find out what is the length of the longest common subsequence. Well, I will use dynamic programming to solve this problem. I have made another video about dynamic programming and you can check that out here. And now I will use that to solve this problem. Well, here I want to define so many subproblems and solve all of them. These subproblems serve as intermediate problems that I define that help me to find out the final result of my problem. So here for these two strings S and T, each of them have their own length. I say that instead of just finding the LCS of these two strings, I find out the LCS for each prefix of the first string and the prefix of the second string. So for each I and J, I define a DP of I and J, which is the LCS of the first I letters of S from 1 to I. Here I'm just writing 1 based, but in my code I will always use 0 based indexing. But here I use 1 based indexing for explanation. Between the S from 1 to I and T from 1 to J. Okay, so I will solve I will find out the result of all of these values. And my final answer is going to be dp of length of S and length of T. So this way I can find out what is my final answer. So the only question is that how can I find these values of dp of I and J? Let me just first give you an example so that you will completely understand what dp of I and J means. So here, if I find out dp of, for example, 3 and 1, it means that it is the longest common subsequence, the length of the longest common subsequence between the first 3 letters of my first string and the first letter of my second string. This is going to be S, so the result is going to be 1. The length of it is 1. So dp of 3 and 1, for instance, is 1. What about dp of 0 and 4? dp of 0 and 4 means that the first 0 letters from the first string and the first 4 letters from the second string. Well, this is 0 definitely, because one of the strings is empty. Also, I can say that what is dp of 2 and 3? dp of 2 and 3 is the longest common subsequence of these two strings, sh and sam. And this is again S, so this is going to be equal to 1. So this is how we defined our dp. So now let's figure out how do we calculate the values of dp. Well, I can say that dp of I and j, is equal to 0 if I is equal to 0. I can say that, let me say, if I is equal to 0 or j is equal to 0. Well, definitely if one of these two values is 0, then I can say that one of the strings are empty, so the longest common subsequence is empty as well. So the result is 0. Otherwise, if both of them are at least 1. So now I know that both I and j are at least 1. There are two cases. I is greater than or equal to 1 and j is greater than or equal to 1. There are two cases. The first case is that S of I is equal to T of j. So I can say that in this case, I have these two strings. Assume that this is the first I letters of my first string and this is the first j letters of my second string. And I can say that I know that these two strings are equal. Well, there's an important thing that we can look at LCS like it's a matching between the letters of the first string and letters of the second string. For instance, here, let me again tell you about my example, Cheyenne and Salmon. Well, in here, I can say that it's like a matching between this S and this S, this A and this A, this A and this A, and this N and this N. So it's like I have found the matching between some of the characters of the second string and some of the characters of the first string. So, and I want to maximize this matching. So here I can say that if these two letters are equal, I can match them up together. So in this case, I can match these two letters with each other. And you need to keep this in mind, that if you don't match these two characters with each other, then you need to remove at least one of them. Because it's not possible that you match this character with some character here and this character with some character here. We cannot have intersection between two of the lines. So it's not possible that you match this one with another character and this one with another character as well. Keep this in mind that I'm just saying it for the first I letters of S and the first J letters of T. So I'm just talking about this subproblem. But in the general problem, it is possible that you match these two characters with other characters. But in this specific subproblem that I'm talking about, it's not possible that you match this S of I with something else, with something behind T of J, and match T of J with something behind S of I. This never happens. So if you don't match them with each other, you need to remove at least one of them. So in this case, if S of I is equal to T of J, I can say that dp of I and J will be equal to maximum of these three values. There are three cases. It will be maximum of these three values. The first one of them is dp of I minus 1 and j minus 1 plus 1. Why is that? It is the case that we match S of I and T of J, and we remove these two characters and recursively find the answer for the I minus 1 first letters of S and j minus 1 first letters of T. So this is one of the cases that I have. The other case is dp of I minus 1 and j. This is where I remove S of I, and also dp of I and j minus 1. This is for when I remove T of J. And I can be sure that in here, always my best answer is always this. The maximum of these three values is always this. But I don't want to talk about it a lot. If you know why it is like that, you can say that in the comments below. But anyway, I know that the answer is one of these three cases. Either I match S of I and T of J, or I will remove one of them. So the answer will be maximum of these three values. This is for when I match S of I and T of J. This is for when I remove S of I, and this is for when I remove T of J. But what if S of I is not equal to T of J? Well, if this happens, I know that I have the same situation as before, but the first case is not possible anymore. So when this happens, I can say that my answer is going to be equal to only these two cases that I remove one of these two characters. dp of I and j is equal to maximum of dp of I minus 1 and j and dp of I and j minus 1. So this is going to be equal to the maximum of these two values. So this is how I can calculate the values of my dp's. And I know that when I or j are equal to 0, these are my base cases. In this situation, dp of I and j is 0. If I and j are greater than or equal to 1, I have two cases. In each of the cases, in the first case, I say that dp of I and j is equal to maximum of these three values. in the second case, I say that dp of I and j is equal to maximum of these two values. So this way I can calculate the values of my dp. And I can report dp of I, size of s and size of t as my final answer. So this is how I can find the LCS of two strings. So now that we know how we can solve this problem, let's go and implement it. The problem that I want to solve is MC from SPOJ, and I want to show you that how exactly can you use LCS to solve a problem. Let me first tell you that what this problem is. Well, this problem tells you that we have two strings, S and T, and the length of these two strings are at most 1,000. And you want to make these two strings equal. And each time you can remove one character from S by paying like $15, or remove one character from T by paying $30. And you want to pay the minimum amount to make these two strings equal. And you have to say that what is that minimum cost that you have to pay. For instance, if we take a look at its example, in the first example, it has AXB and YAB. And the answer to this is 45. Because you can remove this X from the first string and this Y from the second string, and this you can say that the answer is $45. So now let's take a look at how we can solve this problem. Well, I say that in the end, if we look at the string that remains, so first we have a string S and a string T. And our answer is again in a string. For example, here, our answer is AB. The string that remains is AB. I'm saying that this string that remains should be a subsequence of both of the strings. Because from both of the strings, we reached that string by removing some of the characters. So it is the subsequence of both of them. Therefore, I can say that the result should be a subsequence of both of them, and if the length of the result is L, or let me say that the result is a string X. Okay, so I'm saying that if your result is if the final string that remains is a string X, I can say that the price that you pay is size of S minus size of X times 15, because you have to remove all of the other characters from S by paying $15, plus size of size of T minus size of X times 30. So this is gonna be your answer if the final string that remains is a string X. So we can understand that it's better if the length of X is maximum possible. So this problem really wants us to find the longest common subsequence. And then after finding that, we can report this value as our final answer. So we need to find the longest common subsequence, and then using that, we need to answer this. And then using that, we can report the final answer. So let's now start coding it. This problem gives you several pairs of strings, and we need to answer them one by one. So let's first include IOStream. Okay, so we need to define our two strings S and T. And I need to keep getting the input until S is equal to hashtag. So I can say that while C in S and S is not equal to hashtag. Then also C in T, and I need to find the answer for S and T. I can just say solve for S and T. I can just say cout find answer for S and T. Okay, now we define the function find answer. It receives two strings S and a string T. I have also included a string in the beginning of my code. I know that if first I just can find the length of the longest common sequence between S and T, I need to only return s.size minus L times 15 plus t.size minus L times 30. And I forgot to also say int here. And if you wonder what inline means, well, inline is just something that makes your code faster. If you put that before the functions, which are not recursive, which don't call themselves. You can only put inline before the functions which don't call themselves. If you do that, it makes your code faster. If you want me to make a separate video about it and explain that in details, just tell me in the comments and I will make another video about that. So this is how I can return my answer. Now I just need to define LCS for two strings S and T. And I can just say that, as I said, I should define dp of n size n by n, and n is at most 1000 plus 20, because this is my constraint, and the memory complexity is n squared. So I just need to find the values of dp's now. I have my first for on S and my second for on T dot size J plus plus. I just say that, as I said earlier, if I was 0 or J was 0, I say that dp of I and J is 0. I do not need to say this because it is automatically 0. Initially it is 0. But I just say this because I want to make the code more clear for you. Otherwise, else, if s of I minus 1 was equal to t of j minus 1, well, why I added minus 1 to it? Because strings in C++ are use zero-based indexing. So the first letter is s of 0. So I should add this minus 1 here. If this happens, I just say that dp of I and j is equal to maximum of these three values, dp of I minus 1 and j minus 1, plus 1, dp of I minus 1 and j, and dp of I and j minus 1. As I said earlier, the maximum of these two values is always this, and you can prove that. And if you want me, I can explain that in another video too. But because I don't want to make this video very long, I just write all the possible cases. Else, I can say that dp of I and j is equal to maximum of dp of I minus 1 and j, and dp of I and j minus 1. And at the end, it's just enough to return dp of s.size and t.size. And this way I can find out the length of the LCS, and then this value will be returned to find answer, and this way in find answer I can just find the final answer. Now let's test it and see if it works. Okay, let me copy the input. Okay, as we see here, it gives the correct answers for the samples. I have also included several other libraries because in the judge it is possible that it needs other libraries as well. For me, only these two first libraries were enough for my system, but to make sure I need to include other libraries as well to make sure that judge also can work with it. So let us submit it. Okay, as we see, it got accepted, and this is how we can implement longest common subsequence. I just need to also tell you that what is the time complexity of LCS. As we see, dp of I and j is what we use to find our answer. And we know that I is at most at s dot size, length of s, and j is at most length of t. If we assume that the length of these two strings are at most n, I can say that my time complexity will be O of n squared. And also my memory complexity will be O of n squared as well. Because my memory uses 2 dimensions and each of them are at most n, and also my time is O of n squared because I update all of these values of dp's in O of 1. So my time complexity and memory complexity are both up to n squared. Okay, that's it for the longest common subsequence. If you had any questions about it, don't hesitate to ask me about that. I will try to answer all of your questions one by one. Also, if you wanted me to make another video on another topics, tell me and I will surely make videos about that. I'm trying to help you in the best possible way. So if you like my work and you want to support me, you can like this video and subscribe my channel. And also share this video with anyone that you think these videos can help them. Thank you very much.